Hey everyone! Ever stared at a blurry photo, wishing you could zoom in and see every detail? That's where image super resolution comes in. AI magic that turns low-res images into sharp, lifelike masterpieces. But here's the catch. Most models are either fast but blurry or super detailed but super slow. Today we're diving into a game changer, the Large Kernel Modulation Network, LKMN. Let's break down how it's rewriting the rules of image enhancement. So what's the problem with traditional methods? Think of convolutional neural networks, CNNs, as fast sprinters. They process images quickly but miss the big picture. Transformers, on the other hand, are like marathon runners. They capture long-range details like textures or facial curves, but drag their feet when it comes to speed. It's like trying to cook a gourmet meal with a microwave. Convenient, but not exactly restaurant quality. Enter LKMN. This model is a CNN, but with a clever twist, large convolutional kernels. Imagine using a wide brush instead of a tiny paintbrush. These kernels see more of the image at once, capturing both local details like the edges of a leaf and global context like the entire tree. But here's the kicker. LKMN doesn't sacrifice speed. How? Two smart components, the Enhanced Partial Large Kernel Block, EPLKB, and the Cross-Gate Feed-Forward Network, CGFN. Let's start with EPLKB. Instead of tiny 3x3 filters, it uses massive 31x31 kernels. But here's the trick. It only applies them to partial channels of the image. Think of it as painting a mural. You focus your brush on key areas instead of the whole canvas. Plus, it uses channel shuffling and attention mechanisms to prioritize important details, like highlighting the most critical puzzle pieces. Then there's CGFN. This part balances local and non-local features. Imagine solving a jigsaw puzzle. CGFN ensures the edge's local details and the big picture non-local context fit perfectly. It does this with a cross-gate strategy, dynamically adjusting how much each feature contributes. It's like having a co-pilot that fine-tunes the balance in real time. The results? LKMN crushes the competition. On the Mango 1.9 dataset, it achieves state-of-the-art PSNR scores while maintaining 30% faster inference times than traditional CNNs. But researchers aren't stopping there. Ever wonder how AI can turn a blurry photo into a crystal-clear masterpiece? Let's break down the clever tricks researchers are using to make image super resolution smarter, faster, and more efficient, without burning through your phone's battery. First up, Convformer, a 2024 breakthrough that's like a dream team of AI techniques. Think of convolutional networks as the pattern-finding experts. They're great at spotting edges, textures, and shapes. Then there's the Transformer, which acts like a context wizard, understanding how those patterns fit into the bigger picture. By blending these two, Convformer creates stunning images but uses way less power. Perfect for your smartphone camera, which doesn't have a supercomputer in its pocket. But researchers aren't stopping there. Enter SLVR, Super Light Visual Reconstruction, a 2025 game-changer. Its secret weapon? Blueprint Controllable Convolutions, a fancy way of saying it adapts on the fly. Imagine an AI that doesn't just follow a one-size-fits-all recipe, but grabs the right tools for the job. If an image needs more detail in a face, it focuses there. If a background is simple, it skips the extra work. It's like having a flexible toolbox that's both fast and precise. Now let's get a bit experimental. Mamber and Mayer, 2024-2025, use something called state space models. Think of them as AI memory systems. These models don't just look at a single image, they remember patterns from similar images. Ever notice how humans instinctively know how a tree's bark or a sky's gradient should look? These models do the same, filling in gaps with natural, realistic details. Then there's the Dual Aggregation Transformer from 2023. This one splits the work. One part zooms in on tiny details like a magnifying glass, while the other steps back to see the whole scene. It's like having two experts review the same photo, one checking the fine print, the other the overall story. The result? Images that feel balanced, not overly sharpened or distorted. And here's a twist. A 2021 paper called Interpreting Super Resolution Networks made AI more transparent. Using local attribution maps, it shows exactly what parts of an image the model is focusing on. It's like giving the AI a voice to say, I'm paying attention to this edge, this texture, this shadow. This transparency isn't just cool, it's crucial for trusting AI and improving it over time. So what's the big picture? These innovations aren't just about making images sharper. They're about making AI smarter, faster, and more like a thoughtful assistant. Whether it's saving power, adapting to tricky details, or explaining its choices, the future of image super resolution is about efficiency, adaptability, and clarity. And that's a win for everyone from photographers to scientists to your average phone user. Next time you see a stunningly clear photo, you'll know there's a whole team of clever algorithms working behind the scenes. Stay curious, and we'll see you in the next video.